Hi guys, I trust that you're all doing well. I hope that you had a blessed and festive season, and I trust that you're all rested and you've gained your positivity and you're ready for the new year, and that you're ready to make miracles in this year to make things happen. So, welcome to our first live stream. Sorry, this is actually not a live stream. I should say, welcome to our first recording of grade 12 mathematics sequences and series. This is our first lesson for the year. And in this lesson, we're going to be having a look at the following. So we'll be having a look at sequences, three different types of sequences that you assessed in grade 11, sorry, grade 12, your arithmetic, your geometric, and your quadratic sequences. We're going to have a look at the series, the three different series that you'll be doing, the arithmetic series, geometric series, and the infinite geometric series. And we're also going to have a look at sigma notation. So, without any further ado, let's get straight into the lesson. Alright, so patterns or sequences, these are also sometimes referred to as progressions. These occur very frequently in nature as well as in numbers. So for example, if we think of where we use sequences in nature, if you listen to the sound of rain falling on your roof, it forms a certain consistent pattern. If you listen to the sound of a dog barking, for example, or the sound of a cricket, if you listen to the birds chirping, they all form a sequence, they form a pattern. Another example of where we see patterns is if you had to look at the shape of a snowflake underneath a microscope, you would actually see that it forms a very interesting pattern. Also, if you had to look at the colors of the rainbow, the frequencies form a unique pattern. If we look at examples of sequences in numbers, if you look at a set of odd numbers, that forms a sequence. A set of even numbers forms a sequence. A set of real numbers, a set of rational numbers, a set of consecutive numbers, they all form a sequence. Now, in mathematics, a pattern or a sequence is defined as a group of numbers that follow a fixed rule. Now, it's quite important to take note of this. It must follow a fixed rule. So we don't just have random arrangements of numbers. There must be a pattern occurring within the arrangement of these numbers, and that's what we call a sequence. Now, there's many different types of sequences that are found in mathematics. Some of you, if you've done research, you might have heard of the Fibonacci sequence. You might have heard of what we call recursive sequences. But what we're interested in grade 12 is just the three types of sequences, which is your arithmetic or your linear sequence. We have a geometric sequence. Then we also have the quadratic sequence. Let's have a look at each one of them in detail. So your arithmetic sequence. Let's have a look at the following numbers. You've got -8, -4, 0, 4, and 8. Now, pause the video and see if you can actually derive a pattern of what happens in this number. So can you identify the relationship or a rule that describes the relationship between these numbers? There we have a second set of numbers. We've got 3, we've got 1, -3, -5. Once again, pause the video and see if you can figure out what the relationship is or what the rule is that describes the relationship between these numbers. Here's a third set, 15, 45, 75, 105, 135. Can we identify a rule or a pattern that describes the arrangement of numbers? Now, in each of these examples, there's a constant number which was added or subtracted to one term to get the next term. Let's look at the first example. So you've got -8. What number was added to -8 to get -4? Well, that's +4. So -8 plus 4 gives us -4. When we take -4 and we add 4 to it, we get 0. When we take 0 and add 4 to it, we get 4. When we take 4 and add 4 to it, we get 8. So in essence, the constant number in the first pattern that we keep on adding is +4. If we look at the second example, basically here we just keep on subtracting 2. So 3 minus 2 gives us 1. 1 minus 2 gives us -1. -1 minus 2 gives us -3, and so on. The constant number in this case would be -2. The third example, we just keep on adding 30. So 50 plus 30 gives us 45. 45 plus 30 gives us 75. 75 plus 30 gives us 105. 105 plus 30 gives us 135. The constant number in this instance is 30. Now, we have a special name for this type of sequence. This is called an arithmetic sequence. It's also known as a linear sequence. And the number that we keep on adding to one term to get the next is referred to as the common difference. Now let's have a look at the next slide. So the definition of an arithmetic sequence or linear progression. This is a sequence that has the general term Tn equals a plus open bracket n minus 1 times d. So what is this general term that we speak about? What is this so-called nth term as well? Well, the general term, this is a formula that allows us to find any term in any position in the sequence. So let's see, what do each of these variables mean? The value of a, that's the first term in the sequence. D is the common difference. Now, the common difference is that number that we spoke about in the previous slide, that we keep on adding or subtracting to get the next term. N is the position of the term. Now, this is a very important statement. We'll take a look at it in the next slide. And then Tn, that's the general term. Now, to get the common difference, we basically say T5 minus T4. That will give us the same answer as T4 minus T3, which should give us the same answer as T3 minus T2, which will give us the same thing as T2 minus T1. If for some reason T5 minus T4 is not the same as T4 minus T3, please take note that this would not count as an arithmetic sequence. It's not a linear sequence. For us to have a linear sequence, when I subtract consecutive terms, I must get the same answer, which is the common difference. Please take note of that. Something to note about the value of n. Recall that we said n is the position of the term. Now, what do we know about a position? Well, a position cannot be negative. It would not make sense to say you're at position -3. A position cannot be 0. Although we often talk about positions in terms of zeros in our everyday conversation, it does not make sense to have position 0 because you're at position nothing. It basically means you do not exist. A position cannot be a decimal because you cannot have position 3,15. So, we are saying that n is an element of natural numbers. So, n must start from 1 up to infinity, but the value of n has to be positive. Yes. The value of n cannot be a decimal or a fraction. And the value of n, this applies to all of the sequences, not just the arithmetic sequence. So the same thing applies with the other two sequences that we're going to have a look at in just a moment. I hope that this makes sense, and I hope that you guys are still following along. If I'm moving too fast, please do leave a comment in the comment section, and I shall slow down in the next set of videos or re-upload the video if need be. Alright, now we have an example. We have the pattern 8, 11, and 14. And for us to be able to have a look at this example, let's go to our writing pad. So there we are. We've got 8, 11, and 14. Now, I must warn you beforehand that my handwriting is terrible. Please do bear with me. So, let's see. The question says, write down the next 3 terms. So in order for us to be able to write down the next 3 terms, the first thing we need to do is identify if this is a linear sequence. How do I check if this is a linear sequence? Well, let's check if we have a common difference. So if I say 14 minus 11, this is going to give me 3. If I say 11 minus 8, this is going to give me 3. So in other words, my common difference in this case is 3. Here's something interesting to take note of. 8 plus the common difference gives us 11. So I'm just going to write it down on the side. So 8 plus, let me use a different color for the common difference. 8 plus our common difference equals 11. And then 11, which is term 2, plus our common difference, this is going to give us the third term, which is 14. So that should imply that when I want the next 3 terms, I'm going to say 14 plus the common difference, and that is going to give me 17. So that's the first term. I'm going to say 17 plus the common difference, and that is going to give me the next term in my sequence, which is 20. Then I take the same 20 plus the common difference. And this is going to give me 23. So the next three terms of the sequence are 17. So 17, 20, and 23. So whenever you're asked to find the next few terms, however many terms they want, you always need to find the common difference first and then keep on adding the common difference. Let's have a look at the next question. The next question says determine the nth term of the sequence. So we need to find the general term of the sequence. So we know that this is a linear sequence or an arithmetic sequence because we have a common difference. Now I need to say Tn is equals to a plus n minus 1 multiplied by d. So a is our first term, which is 8 plus n minus 1 multiplied by my common difference, which is 3. What I like to do is I like to take the common difference and actually put it before the bracket so that it makes it easier for me to multiply out. So this is just going to give me 8 plus 3 times n, that's 3n. 3 times minus 1 is minus 3. This is going to give you 3n, 8 minus 3, that's going to give you 5. This is my general term, this is my nth term. Wonderful, I'm done. If it so happens that you want to test if your nth term is correct, now I'm not going to do it here, but just something that you can do as a side note, you don't have to do this in your exam, is substitute n is equals to 1 into the general term and see if it actually gives you the value of 8. If it does, then your general term is correct. You can substitute n is equals to 2. If it gives you 11, your general term is correct. Like I'm saying, this is not something that's compulsory for you to do. You could just do it when you want to check if your general term or your nth term is correct. Let's move on to the next question. So the next question says determine T57. So we're looking for the 57th term. So the first thing I need to do is I need to write down my general term again. So this is going to be 3n plus 5. To get T57, we need to take note that the value of n is 57. So T57 is going to be equals to 3 times 57 plus 5. That's going to give you, let's see, 57 times 3. So let me just do it on the side, 57 times 3. So 7 times 3, that's 21. Carry the 2. 5 times 3, that's 15. 15 plus 2 is 17. So my answer is 171 plus the 5. This gives us 176 as term 57. I hope and trust that this made sense. Let's move on to the next question. Which term in the sequence has a value of 253? So, what we're told in this instance is we need to find out the value of n for which Tn is equals to 253. So we need to find out what is the value of n. Now, remember that first question, or was it the second question that asked us to determine the general term? We still need to use the general term in order for us to determine the value of n, which will give us the value of Tn is 253. So, Tn is equals to 3n plus 5. Now, 253 is equals to 3n plus 5. So, 253 minus 5 is equals to 3n. 253 minus 5, let's see, that's going to give us 248 is equals to 3n. Divide this by 3, divide this by 3, and when I divide this by 3, I'm going to get a very interesting answer. The value of n is actually 82,66 recurring. Now, remember what we said earlier on. The value of n cannot be negative. The value of n cannot be a fraction. The value of n cannot be 0. But now, since we have a value of n here, which is a decimal, it simply means that 253 does not exist in the sequence. So just take note, if it happens that the value of n violates the 3 rules that we said earlier, meaning n is positive, n cannot be 0, n cannot be a fraction or decimal. If it happens that the value of n is any one of those, it simply means that the term does not exist in the sequence. I hope this made sense. I hope you guys are enjoying the lesson and that you are at least benefiting from this. If you are, please do give us a thumbs up and please do subscribe to the channel so that this video can reach many more people. Alright, without further ado, let's move on. We've got another pattern now. So we've got 16, 22, 28. Let's write this down on our writing pad. So we've got 16, 22, and 28. By now you can surely guess what the next question is going to be, what the first question is going to be. Write down the next three terms. Wonderful. So we said to get the next three terms, we need to test if this is an arithmetic sequence. We do this by saying 28 minus 22, that's going to give us 6. 22 minus 16, that's still going to give us 6. We have a common difference. The value of the common difference is equals to 6. So to get the next three terms, I'm going to say 28 plus 6, and that's going to give us 34. I'm going to say 34 plus 6, that's going to give us 40. And then I'm going to say 40 plus 6, that's going to give us 46. And there we have our next three terms. I hope this made sense. All right, let's look at the next question. Determine Tn. We're determining the general term. So once again, in determining the general term, we're going to say here, if I could get my pen to write, Tn is equals to a plus n minus 1 multiplied by d. So the value of a is our first term, which is 16. So this is going to be 16 plus n minus 1 multiplied by 6. Once again, like I said, I always bring the coefficient to the front of the bracket so that it's easier for me to multiply out. This is going to be 16 plus 6n minus 6. 16 minus 6, that's going to give us 10. So I've got 6n plus 10. This is my general term. This is my nth term. I am done. Wonderful. Let's look at the next question. Prove that all the terms in the sequence are even numbers. Right. I like this question because it's not a very straightforward question where you just have to substitute and get a once-off answer. So let's look at our general term. Tn is equals to 6n plus 10. What do we know about even numbers? All even numbers are divisible. Some of you would say divisible. They're divisible by 2. So in other words, what I need to do here is I need to check, can I factorize this expression? Can I take out a common factor? Let's see. My common factor is indeed 2. Then I remain with 3n plus 5. Now when looking at this, I've got a coefficient of 2. This automatically means that all of the terms in the sequence are multiples of 2. So I'm just going to write this here. All terms are multiples of 2. Meaning that 2 can go exactly into those terms. Because all terms are multiples of 2, it therefore means that all terms are even numbers. I trust that this makes sense, and I hope that you guys understand how to approach such a question. All right, let us look at the next section. All right, in the next section now we're looking at geometric sequences. Once again, we have a set of numbers, 2, 4, 8, 16. As another exercise, pause the video and see if you can figure out what the relationship is here, what the rule is that describes the relationship between each of the consecutive terms. The next sequence we have is 9, 3, 1, a third. Once again, pause the video and see if you can determine what the relationship is. We've got 24, we've got 12, we've got 6. Once again, pause the video see if you can come up with the relationship here. Assuming that you actually have paused the video and looked at it, which I really advise that you do, for the sake of following along and also to expand your own thinking capacity, you would realize that in the first sequence, all of these terms are powers of 2. What does that mean? 2 times 2 gives me 4. 4 times 2 gives me 8. 8 times 2 gives me 16. In other words, to get the next term in the sequence, I just keep on multiplying by 2. The next sequence, you will notice that these are all descending powers of 3. So 9 divided by 3 is 3, 3 divided by 3 is 1, 1 divided by 3 is a third. So getting the next term in the sequence just involves dividing by 3 or multiplying by a third. When we look at the third sequence, we've got 24, we've got 12, we've got 6. What's happening here is we just keep on dividing by 2. 24 divided by 2 gives me 12. 12 divided by 2 gives me 6. So we just keep on dividing by 2. In each of the patterns, as we have already figured out, there's a constant number. We call this number a constant ratio. We have to multiply it or divide it to one term to get the next term. Such a type of a sequence is known as a geometric sequence. Now, what are the properties of geometric sequence? So geometric sequence or geometric progression or geometric pattern, it's a sequence that has the general term Tn equals ar to the power n minus 1. Let's see what each of these variables mean. A is the first term of the sequence, similar to what we have in the arithmetic sequence. R is the common ratio. N is the position of the term. Remember what we said about the position of the term earlier on? The position cannot be negative. The position cannot be a fraction. The position cannot be 0. All right. Tn is the nth term. So here we've got an example. 6, 12, 24. Let's go to our writing pad so that we can analyze this. So we've got, let me open up a new sheet so that we don't confuse our work. We've got 6, 12, and 24. Certainly by now you can already guess what the first question is, but let's have a look at it. Determine the next 3 terms. So what we need to take note of here is that if we try and establish a common difference, let's see, 24 minus 12 gives us 12. 12 minus 6 gives us 6. We do not have a common difference here. So this cannot be an arithmetic sequence. This is not a linear sequence. So let's see if there's something else that we could do here. Let's see. If I had to decide to take 24 and divide it by 12, I'm going to get 2 as an answer. If I'm going to say 12 divided by 6, I'm going to get 2 as an answer. So something that I forgot to mention in the notes actually is that to calculate the common ratio, you will use the general expression Tn divided by Tn minus 1. So in other words, this is the same as saying T4 divided by T3 is equals to T3 divided by T2, which is equals to T2 divided by T1. I had a bit of an issue here with space. So the value of R that we calculated here is 2. The value of A, our first term, is 6. But let's not get ahead of ourselves. Let's check what the question actually said. We need to determine the next 3 terms. So to get the next terms, let's just look at this. 6 multiplied by my common ratio gives me 12. 12 multiplied by my common ratio gives me 24. It means 24 multiplied by my common ratio is going to give me the next term, which is 48. 48 multiplied by my common ratio, that's supposed to give me, let's see, 48 times 2, that's supposed to give me 96. Then 96 multiplied by my common ratio, so 96 times 2, it's just going to give us, if my pen could work, that would be great, 192. So there we are, we have determined the next 3 terms. We are done. Life is great. Let's go back to the questions and see what the next question is. Determine Tn, the general term, the nth term. So, because this is a geometric sequence, the Tn is equals to ar to the power n minus 1. This is going to give me 6 times 2 to the power n minus 1. This is my general term, life is great. Okay, there's an elephant in the room that I need to address. I've seen some learners doing this. So you've got Tn is equals to 6 times 2 to the power n minus 1. Then I've seen some learners saying 6 times 2 is 12 to the power n minus 1. Ladies and gentlemen, boys and girls, this is absolutely wrong. According to laws of exponents, the only time I can multiply the 6 and the 2 is if I have something like 6 to the power n minus 1 times 2 to the power n minus 1. So if I have exactly the same exponents, only then can I multiply the bases. Please take note, we do not multiply the 6 and the 2. Please take careful note of that, because a lot of you guys, what you would do is you would write the correct answer, then you go ahead and make this mistake, and then before you know it, your answer's wrong, and then you ask yourself, but what went wrong? Does the marker not like me or something? Please take note of these pitfalls, because this is actually what determines whether you could potentially get a distinction or just have average marks. Simple things like these. Okay, let's move on to the next question. Use a calculation to explain why 258 is not a term in the sequence. All right. When is a term not present in a sequence? If the value of n is a decimal or a fraction or 0. But let's have a look at it. So if I go back up again and I look at my general term, Tn is equals to 6 times 2 to the power n minus 1. Let's quickly go back to the notes and see what the question said. We need to explain why 258 is not a term in the sequence. So what I'm going to do here is, let me pretend 258 is actually a term in the sequence. I'm going to substitute 258 here is equals to 6 times 2 to the power n minus 1. Now, according to the laws of mathematics, we know that we need to divide both sides by 6. So I'm going to divide this by 6 and I'm going to divide this by 6. I'm going to get my answer of 43 is equals to 2 to the power n minus 1. Of course, this and this is going to cancel out. Already, when you have a look at this, you will get to realize that, okay, 43 cannot be expressed as a base of 2. In fact, for those of you that know logarithms, you might realize that you could say n minus 1 is equals to the log of 43 base 2. If you don't understand what's happening here, it's okay, because you're still going to cover logarithms when you're dealing with functions. If you're an IEB learner, you're more or less familiar with what's happening here. What you will actually realize is by doing this calculation, you're going to end up with a setup in which you have a decimal. And because we have a decimal value for n, it means that 258 does not exist in the sequence. Why? Because the value of n is not a natural number. I hope this makes sense to you guys, and I hope that you will remember this in an exam to say, if it happens that the value of n is a decimal or a fraction or negative, that the term does not exist in the sequence. I hope this example made sense. Let's move on to the next section or the next question. All right, now we're given a very interesting pattern, 3,125, 625, and 125. Let's write down these terms. Let me just open a new sheet so that I can have sufficient space. So I've got 3,125. I've got 625, and I've got 125. All right, let's go back to the question. So the question says, explain how you would find the next term of the sequence. Okay. See, I like questions like these where you have to explain, because you're going to use a calculation to explain in any case. So the first thing you have to do is you need to find the common ratio. So I can find the common ratio by saying my common ratio is 125 divided by 625, and that's going to give me 1 over 5. So I have my common ratio, which is 1 over 5. But we haven't answered the question. The question said explain how you would get the next term. So to get the next term, I am going to multiply 125, which is the last term we have here, by 1 over 5. That will give me the next term. Now, because the question said explain how you would find the next term, it's not necessary for you to actually find the next term, but if you want to, if you're in a good mood, just take note that the good moods are not always applicable in the exam because they take up time. But for the sake of being in a good mood right now, I'm going to say 125 multiplied by 1 over 5. This is going to give me term 4 as 25. I hope that this makes sense. All right, let's have a look at the next question. The next question says determine the general term. Okay, fair enough. We already determined that this is a geometric sequence, so Tn is equals to AR to the power n minus 1. Let's go back up to the sequence. So the value of A, our first term is 3,125. The value of R is 1 over 5. So I'm just going to substitute this. Tn is equals to 3,125, open bracket 1 over 5 to the power n minus 1. And I can leave it there. For those of you who know for those of you who understand laws of exponents, you could go ahead and simplify this further, but I'm just going to leave it like this for the sake of simplicity. As I've mentioned, if you do want to simplify, you can continue further, but for the sake of simplicity, let's keep it right here. This is our general term. That's a terrible line, but anyways, let's move on to the next question. Just so that you guys see what I did there, because I saw that went off screen. So we wrote down our general term, substituted the value of A and R, and from there you can simplify if you want to, but keep it simple. All right, let's look at the next question. Which term in the sequence has a value of 244,140,625? All right, I like this question. Let's go to our writing pad. This time, let's make sure all of us are on the writing pad. So we have Tn is equals to 3,125 into 1 over 5 to the power n minus 1. So that number again, 244,140,625 is equals to 3,125 into 1 over 5 to the power n minus 1. I can divide this by 3,125, and I can divide this by 3,125. This is going to cancel this. I am going to remain on this side with 1 over 5. You know what? Let me write it on the next line so as to make it neater. So let's get rid of u here. And let's put this on the next line. So we have 1 over 5 to the power n minus 1. So 344,140,625 divided by 3,125. That's going to give me 78,125. When I get to this point, I can express both sides as bases of 5. So I could say this is 5, let's see, to the power 7. And this is going to be equals to 5 to the power negative 1 to the power n minus 1. Right. Laws of exponents. See, this is why algebra is so important in any section of mathematics. Let's multiply out the brackets. So 5 to the power 7 is equals to 5 to the power minus n plus 1. Bases are the same. Let's drop the exponents. So 7 is equals to negative n plus 1. Let's take the negative n to the other side. So n is equals to, let's see, did I make a mistake somewhere? No. Did I? That's supposed to be negative n plus 1. All right, I did not make any mistakes. So I'm going to have here 1 minus 7. But now 1 minus 7 is going to give you n as negative 6. Because the value of n is negative, 244,140,625 does not exist in the sequence. I hope you guys are beginning to understand the working behind patterns and how to determine whether a term exists in a pattern or does not exist. Anyways, let's move on to the next section. Now we're going to talk about the quadratic sequence, the quadratic pattern, the one you remember from grade 11. Right, a quadratic pattern. This is a pattern with the following properties. The sequence of first differences form an arithmetic sequence. The second difference is constant. So basically what we're saying here is a quadratic sequence is like a linear sequence in a sense that it has a difference. But now it has a second difference. And the second difference is constant. First difference always forms an arithmetic sequence. The general term of a quadratic pattern is, as we can see here on screen, Tn equals an squared plus bn plus c. All right. Sometimes you will be asked to find the maximum or the minimum of a quadratic sequence. A quadratic sequence only has a maximum if the value of a is negative and n is an element of natural numbers. Once again, if you go back to what we said on page 6 about the value of n, it cannot be 0, cannot be a decimal, cannot be negative. So if the value of a is negative, we assume there's going to be a maximum. But the maximum only exists if n is an element of natural numbers. Please take note of this. A quadratic pattern has a minimum value if a is positive and n is an element of real numbers. Sorry, n is an element of natural numbers. So once again, if the value of a is positive, we have a minimum value. I know it seems like it's slightly switched around, but this is how you can think of it in terms of functions. So if the value of a is positive, your graph is concave down and therefore you've got a maximum value at the turning point. Then if the value of a is positive, your graph is concave up, you have a minimum value at the turning point. To calculate the maximum value of n, to calculate the value of n where the sequence is a maximum or minimum, we could use our normal turning point equation. Now, for those of you who would prefer completing the square, you can complete the square and then take the value of p as your maximum or minimum. To get the actual maximum, you have to substitute the value of n back into Tn, because remember, the calculation that we did up here only told us the value at which we can find the maximum or the minimum. It only gave us the value of n, the position where a maximum or minimum might potentially exist. It does not tell us what the maximum or minimum actually is. All right, we have another example, so let's go back to our writing board. And because this is a new sequence, let's start it on a blank page, blank sheet. It's a new year after all. So we're given the pattern 1, -4, let's see, -15, and -32. Let's check what the question says. Write down the next two terms. Now, this is an interesting one. I've seen learners determining the general term or the nth term, and then they substitute, because let's look at this. This is term 1, this is term 2, this is term 3, this is term 4. So what some learners would do is they will determine the general term and then substitute 5 into the general term so as to get the next term, substitute 6 into the general term to get the next term. Well, the next question is most likely going to ask you to determine the general term, so you wouldn't want to do twice the work. Here's an easy technique that I've found out. If I say T2 minus T1, I'm determining the first differences now. So -4 minus 1, that's going to give me -5. Then I say -15 minus -4, that's going to give me -11. Then I say -32 minus minus 15. So that's the same as saying negative 32 plus 15, and it gives me minus 17. So minus 17. I can now find my second differences by saying negative 11 minus minus 5. So that's the same as saying negative 11 plus 5. This is going to give me negative 6. Negative 17 minus minus 11. That's the same as saying negative 17 plus 11. That's still going to give me negative 6. So how do we determine the next two terms as the question asked us? This is what I would do. I would say, okay, let me just change colors here. I know that negative 5 plus negative 6 gives us negative 11. Negative 11 plus negative 6 gives us negative 17. So that should tell us negative 17 plus negative 6. So let's see. Negative 17 plus negative 6. Negative 17 plus negative 6. Let's see. That's going to give me negative 23. So let me just put this down here. If my pen could respond properly, I'd be very happy. Negative 23 there. Now I could go ahead and say negative 23 plus minus 6. And that's going to give me negative 29. Now why am I doing this? Check this. Let me use a different color. I know this is going to be a bit messy, but 1 minus 5 gives us minus 4. Minus 4 minus 11 gives us minus 15. Minus 15 plus 17 plus negative 17 gives us minus 32. Minus 32 plus minus 23. That's going to give us the next term. So minus 32 plus minus 23. That's going to give us, let's see, negative 55. Negative 55 plus minus 29. It's going to give us negative 84. There we are. I have determined the next two terms. I hope this makes sense for you guys. Let's have a look at the next question. Determine the general term in the form Tn equals an squared plus bn plus c. Right, there's many different ways of doing this, but this is the easiest approach I take. I would say 2a will be equals to my second difference. So 2a is going to be equals to negative 6. I can solve for a. Divide by 2, divide by 2. A is equals to negative 3. Next, I could say 3a plus b is equals to the first term of the first differences, which is going to be negative 5. Now remember, I already have the value of a that I calculated down here, so let me substitute that. 3 into negative 3 plus b is equals to negative 5. This is going to give me negative 9 plus b is equals to negative 5. B is equals to negative 5 plus 9. You get b is equals to 4. There we are. We've solved for b. Now we want to get the value of a. Sorry, the value of c. A plus b plus c is equals to the first term of the original sequence. So a plus b plus c is going to give me 1. But the value of a is negative 3. The value of b is 4. The value of c we don't know, and this is going to give us 1. Negative 3 plus 4, that's 1. Plus c is equals to 1. C is equals to 1 minus 1, and therefore c is equals to 0. Now, let's write down our general term. So Tn is equals to an squared plus bn plus c. Let's see. Now we could substitute what we have. Negative 3n squared plus 4n plus 0, which is just going to give me negative 3n squared plus 4n. This is our general term. I hope it makes sense. I know it was a bit tricky in the section where I said we need to determine the next two terms. If it did not make sense, please do let me know in the comment section and I will create a separate video where I cover how to find terms in a quadratic sequence. Other than that, let's look at the next question. Does the sequence have a maximum? Explain your answer with the relative calculation. Remember what we said. A maximum exists potentially if a is negative. Now the value of a here is negative. We've got a being -3. Let me write that properly. We've got the value of a which is -3. So a is negative. But now we need to check whether we have a maximum or not. And to determine that, we need to say n is equals to -b over 2a. This is going to be negative. The value of b is 4 over 2 into the value of a, which is -3. Let's see what this is going to give us. So this is going to give us positive 4 over 6, which is going to give us 2 over 3. Since n is not an element of natural numbers, we could say that there is no maximum. So the maximum only would exist, yes, if a is negative, but remember the rule of n, that n must be an element of natural numbers. In this case, n is not an element of natural numbers, therefore we do not have a maximum. I hope this was clear to you guys. Once again, I know I speak a bit fast, or maybe I speak a bit too slow. If you feel my speed is not proper enough, please do let me know in the comment section so that in the upcoming videos, I can adjust my speed appropriately and if need be, like I said, recreate this video. Alright, let's have a look at the next section. Right, now we're given a quadratic sequence that already has a general term. So let me write that down on the writing pad. We are given Tn is equals to n squared plus 4n plus 3. All right, let's go back to the notes. Which terms in the sequence will have a value of 0? Okay, lovely. Let's go back to our writing pad and answer this. So which term will have a value of 0? That simply means that the value of Tn is equals to 0. So 0 is equals to n squared plus 4n plus 3. What does this look to you like? It looks like the famous solve for x question where you're solving for a quadratic equation. So you could go ahead and use your quadratic formula. So you could say n is equals to -b plus or minus the square root of b squared minus 4ac all over 2a. Or if you look at the expression, let me write it down again. 0 is equals to n squared plus 4n plus 3. You can actually factorize this. So let us factorize this. We're going to have n here and n there. The last term is positive, so signs must be the same. Because the middle term is positive, both signs are going to be positive. I'm going to have 3 and 1 because 3 times 1 is 3, but 3 plus 1 is 4. N is equals to -3, n is equals to -1. If you're going to sit there in your exam answering such a question and then you think you're done, my friend, I've got bad news for you. Notice that the value of n is negative, so 0 does not exist in the sequence. Remember this. It is, and notice I've deliberately chosen these examples whereby the value of n is negative or fraction or 0 because I want you to pay attention to how you could potentially get pranked. Yes, you do get pranked in an exam. All right, let's look at the next section. Determine the minimum value of the sequence. All right, once again, the value of a is positive, so indeed we do have a minimum. Or let me say we potentially have a minimum. So because the value of a is 0, we have a minimum. So n is equals to -b over 2a. This is going to give you negative 4 over 2 into 1. And this is going to give you negative 1. Once again, the value of n is negative, so the minimum does not exist. I hope we're clear on this one. Alright, let's go back to the next section. I hope you guys are enjoying the video and that you're finding it productive. Please do give a thumbs up, leave a like or share, and let's have more people getting a hold of the video. Alright, now we move into a new section in grade 12, a series. Now, when we're talking about a series, you guys, we're not talking about the thing you're watching on TV. We're not talking about Game of Thrones or I don't know what series you guys watch, but we're not talking about that. In mathematics, a series is the sum of terms in a sequence. So, what do we mean? If we have a sequence T1, T2, T3, a series would be T1 plus T2 plus T3. So the difference between a sequence and a series is a sequence, you can think of it this way, has semicolons because it has to separate the values. But a series has pluses because we are adding the values. All right. Notice that the nth term, which is the general term, I'm placing special emphasis on the term because that's for sequence. We show the term by Tn. The sum of n terms or the series is represented by Sn. So, general term or pattern, Tn. Sum or series, Sn. Hope that makes sense. There are three types of series that you will encounter in grade 12. We've got the arithmetic series, I'm sure you've guessed it. We've got the geometric series. Then we have something called an infinite geometric series, which is essentially the same as your geometric series, but it has a special property to it. Let's have a look at each one of them. So we start off with the arithmetic series. Simple definition of an arithmetic series, it's the sum of all of the terms in an arithmetic sequence. Now we have a formula for an arithmetic series. This formula, it should be provided to you in your formula sheet, and it is provided, but I would recommend that you know this formula like the back of your hand. Sn represents the sum of the first n terms. Please note, we're not talking about the first term or the fifth term. We're talking about the sum of n terms. A is the first term of the sequence or the series. N is the number of terms. Notice that this time we're not talking about position. It's the number of terms. But also take note that the same thing applies. If I ask you how many brothers and sisters do you have, you can't tell me you've got 3,5 brothers. I mean, is he a brother or not? You can't tell me you've got negative 15 brothers. It would make sense to say you've got 0 sisters. But then again, the sum of 0 terms is just 0. Nevertheless. If the last term of the sequence is known, you can use the second formula where we actually have L representing the last term. Now, something that you need to know is you will be assessed on how to prove these formulas. In other words, in your exam, there's going to be a question for about 4 or 5 marks in which you'll be expected to know how to come up with these formulas. You'll be expected to know how to prove these formulas. Now, here's a question that expects us to prove the formula for an arithmetic series. And to do that, let's go back to our writing pad. Life is great, you guys. All right, new sheet. So, the formula we have here is Sn is equals to n over 2, open bracket 2a, plus n minus 1 times d, close bracket. So how do we proceed in proving this? Well, the first thing you need to remember, Tn, which happens to be your last term, is given by a plus n minus 1 times d. This is for your arithmetic sequence. Okay. The first term of an arithmetic sequence we said is a. To get the second term of an arithmetic sequence, we take the first term and add the common difference. if you can remember. If you don't understand what's going on here, basically what you do is you say T2 is equals to, take the formula for Tn and substitute n is equals to 2. So a plus 2 minus 1 times d, this is just going to give you a plus d, just like that. To get the third term, we will say, take the second term and add d to it. So that's going to be a plus d, which is going to give you a plus 2d. Or, if you'd like to, you could simply use the same approach we used above. So T2 is equals to a plus, now we're substituting 3 into the value of n, and this is going to give you a plus 2d. Right. To get T4, which is the fourth term, we add the common difference to the third term. So that's going to be a plus 2d plus d, which is going to give us a plus 3d. Once again, if you want to use the approach that we used up here, if I could just get my pen to respond, we're going to have this is supposed to be T3. T4 here is going to be a plus, substitute n is equals to 4, and this is going to give you a plus 3d. Cool. You could go ahead and find the fifth term, but that's not necessary. Just remember that we have our last term as well, which is given by a plus n minus 1 times d. Now, let's continue with the proof. Since we know the first few terms, I can say Sn, the sum of the first n terms, is going to be my first term plus my second term plus my third term plus my fourth term plus my fifth term, if I had a fifth term, plus my sixth term, plus my seventh term. Notice that I placed ellipses here, and the function of the ellipsis is just to indicate that, you know what, the pattern continues indefinitely. Now let's take a look at something here. When we are moving from the first term, we keep on adding the common difference. As we approach the last term, we start subtracting the common difference. Now, this is how I like to think of it. When you're moving from home to school, think of home as your first term. The distance between you and home is increasing. Our common difference is increasing. But the distance between you and the school is decreasing. So as you're approaching the school, the distance between you and the school is decreasing. So since I'm approaching my last term, I'm going to start subtracting the common difference. Subtract the common difference. And I'm going to end up here with L minus D. And then eventually I end up with the last term. So just to explain what we did here again. We start by adding all of the terms, term 1 plus term 2 plus term 3 plus term 4. As we move from the first term, the common difference increases. We add the common difference. As we approach the last term, the common difference decreases. We subtract the common difference from the last term. That's the first part of the proof done. Now to get to the second part, we could basically take this sequence and write it in reverse, because when you were in primary, they taught you that 5 plus 3 is the same as 3 plus 5. So how's about we take this Sn that we have up here, let's write it in reverse. I'm going to start with my last term, then it's going to be L minus D, then it's going to be L minus 2D, then it's going to be L minus 3D. We're going to have the ellipsis again. Then we're going to have a plus 3D and a plus 2D. We'll have down here a plus D, and then lastly we'll have a. So we just took the original Sn that we had up here, then we wrote it in reverse. Now, let me get a straight line here. Straight line is good. And let me draw my straight line here. What I'm about to do now is, I'm about to add Sn plus Sn. So Sn plus Sn, you would remember that it gives you 2Sn. Notice, a plus L gives you A plus L. Now let's have a look at something. A plus D plus L minus D. The D's are going to cancel out because we've got positive D and a negative D. What do we remain with? A plus L. If I look at the third term, let me just come up with a different color. If we look at the third term in each of the series, in each of the two Sn values, we will see that A plus 2D plus L minus 2D. The D's cancel out because of the different signs that they have. And what do we remain with? Once again, we remain with A plus L. I guess you can see the pattern now that even if I had to take A plus 3D and L minus 3D, I'm still going to end up with A plus D. Then I have my ellipsis. I have L minus 3D plus A plus 3D. The D's cancel out. This is still A plus L. This is still going to be A plus L. This is going to be A plus L. And lastly, L plus A, that's the same as saying A plus L. Now, here's an interesting part. How many times are we adding A plus L? We don't know. Remember, the N indicates, the N that we have here on Sn indicates, add these N number of terms. So if it was 5, add these 5 terms. If it was 12, add these 12 terms. Because we have N here, we do not know, we are not sure how many times we are adding this. In fact, the ellipsis here should be an indicator to you to say there's an infinite number of terms that we have. So I'm going to say, let me take 2Sn, and because every term is A plus L, let me just multiply A plus L by the value of N because I don't know what the value of N is. I can divide the side by 2 and divide the side by 2. Already you're seeing, if you can remember from the slides earlier, we have already proven the first part of the formula. Let me just go back to the slide so as to show you which formula I'm talking about. So we already are at this point. We've proven this part of it. But now the question that we have here said we need to prove the first part of the formula. So let's go back to our writing board and see how can we accomplish this. If I scroll up a little bit, you would remember that we said L is A plus N minus 1D. So in this formula, where I see L, I'm going to put that A plus N minus 1D. So I'm going to have N over 2 into A plus N minus 1 times D. If you're wondering where this is coming from, we said L is equals to A plus N minus 1 times D. Now when I get to this point, Sn is equals to N over 2 into A plus A, that's going to give you 2A plus N minus 1 multiplied by D. This is exactly the formula that we had to prove. As I mentioned earlier on, the formula, the proof of the formula is worth 4, if not 5 marks. I hope this made sense to you guys. I know it's a bit of a lengthy process, but it's a free 4 or 5 marks. Just understand the working, internalize it, then when you get to your exam, you just regurgitate it. All right. Next question says, determine the sum to 20 terms of the sequence 4, 7, 10. So once again, it's a new year, so a new sheet. We've got 4, 7, and 10. Oops, sorry, you guys are not seeing it. There we are. The question said we need to find the sum to 20 terms. This is telling us the value of n is 20. So what we can do is, let's see, is this an arithmetic sequence? 10 minus 7 is 3. 7 minus 4 is 3. This is an arithmetic sequence. So D is equals to 3. The first term, which is A, this is 4. So I can go ahead and say Sn is equals to n over 2 into 2a plus n minus 1 times d. This is going to give me 20 over 2 into 2 times 4 plus 20 minus 1 times 3. 20 divided by 2, that's going to give you 10 into 2 times 4 is 8 plus 3 into 19. So this is going to give you 10 into 8 plus 19 times 3, that's 57. 8 plus 57, let's see, 57 plus 8, 8 plus 8 is 16, so that should give me 65. So I'm going to have 10 into 65 here, which should give me 10 times 65, that should be something like 650. My answer is 650. So in other words, S20 for the sequence is 650. Notice that we did not have to determine the general term because the question is not concerned with the nth term. The question is just concerned about finding the sum of the first 20 terms. Hope this made sense to you guys. Let's look at the next section. Consider the sequence 1, 2, 3, 4, 5. Sure, you guys are familiar with that sequence. You've heard it somewhere. In your childhood, maybe? I don't know. So, 1, 2, 3, 4, 5. Let's go back to the question. Show that the sum of the first n terms of the above sequence is that. Okay. So just to copy this down onto our writing board, writing pad, Sn is equals to n over 2. Let's find that sum again. Oh, right. So this is going to be n plus 1 all over 2. Right. We need to prove that the sum of n terms is given by this. Okay. Let's ignore the expression for now. Because we are not given a fixed number of terms, the value of n is going to be n. So there's n number of terms, meaning the sum continues into infinity. The value of a, our first term in the sequence, is equals to 1. The value of d, the common difference, 5 minus 4, that's 1. 4 minus 3, that's 1. 3 minus 2, that's 1. So the value of d is 1. We could substitute into our equation Sn is equals to n over 2 open brackets 2a plus n minus 1 times d. This is going to give us n over 2 into 2 times 1 plus n minus 1. The value of d is 1, so I need not write it. But anyways, this is going to give me n over 2 into 2 plus n minus 1. Now, let me just match up with the brackets there. 2 minus 1, that's going to give us 1. So this is n over 2 into n plus 1. I'm done. There we are. We have proven exactly what they asked us up there. This was a very nice question, a very interesting question. Let's move into the next section. How many terms must be added to get the sum of 1,275? Okay. So that 1,275, that's Sn. So Sn is equals to 1,275. We still do not know what the value of n is. We need to calculate the value of n. So Sn is equals to n over 2 into n plus 1. 1,275 is going to be equals to n over 2 into n plus 1. I can multiply both sides by 2 so that I can at least get rid of the denominator that we have here. I want to get rid of the fraction. So I'm going to remain here with n into n plus 1. On the other side, let's see what we have. This is going to be 2,250. Now, when we get to this side, you do not just equate n to 2250 or n plus 1 to that. It only applies if it's a 0. So we need to multiply out everything. 2250 is equals to n squared plus n. Let me open up a new sheet because I've run out of space. So new sheet. And let's just continue where we left off. So I'm going to have n squared plus n minus 2250 is equals to 0. I could just go ahead and solve for n in this case. So I'm going to use the quadratic formula. N is equals to negative b plus or minus the square root of b squared minus 4ac divided by 2a. So let's see. This is going to be negative 1 plus or minus the square root of 1 squared minus 4 into the value of a is 1, the value of c is negative 2250. All of this divided by 2. So n is going to be equals to negative 1 plus or minus the square root of, this is 1, and then 4 times 2250, let's see, 2550. Oops, I made a little bit of a typo in this question. Let me quickly correct my error. Sorry about this. Where is my eraser? There. This is supposed to be 2550, not 2250. So let's just correct this. You see, if I hadn't identified this error now, we would have gotten problems when having to calculate the value of n. So 2550, 2550, 2550. There we are. And now we need to calculate the value of n. So 2550 times 4, that's going to give us, this is 1 plus 10,200. Interesting numbers divided by 2. So n is equals to negative 1 plus or minus the square root of 1. This is going to be 10,201 divided by 2. I love where this is going. See, sometimes when you're working with these big numbers, it might seem daunting at first, but if you're consistent in your calculation, you would actually get to realize it's a very simple answer. But anyways, let's find the square root of 10,201. This is going to give us 101. Life is great. So this is 101 divided by 2. Now I can separate them. So n is equals to negative 1 plus 101 over 2. N is equals to negative 1 minus 101 divided by 2. I'm going to have here, on the one side, n is equals to 100 divided by 2. So n is equals to 50. Life is great. On the other end here, n is going to be equals to, that's going to give me negative 102 divided by 2, which is going to give us n as negative 51. In this case, n is not applicable. So here it's not applicable. Why? Because the value of n is negative. Since the value of n is positive here, it's not a fraction, it's not 0. It means we have to add 50 terms in order for us to get the answer of, what was the question? 1275. I hope this made sense to you guys, and once again, please do subscribe and let this information reach people, and let's share. All right, let's move on to the geometric series. The geometric series is the sum of all the terms, or the sum of terms in a geometric sequence. The formula for geometric series is given as this. Once again, you also need to know how to prove this. A is the first term of the series, R is the common ratio, N is the number of terms. The formula can also be written in the second form where R is negative, or let me say when R is less than 1. You're also required to know the proof of this. And in the next question, we're supposed to find, or we're supposed to prove the sum of a geometric series. So let's open a new sheet of paper. Sn is equals to a into, let me show you guys the sheet, r to the power n minus 1 all over r minus 1. Okay, so once again, you need to remember Tn is equals to ar to the n minus 1 for geometric series. So T1, our first term is a. To get T2, we take the first term and multiply it by the common ratio. As we did with the arithmetic sequence, you could say T2 is equals to ar to the power 2 minus 1, which is just going to give you ar. Lovely, wonderful. T3 is equals to ar squared. Basically, I'm taking the second term and multiplying it by r. So ar times r, that's going to give us ar squared. If that confuses you, then T3 is equals to ar to the power 3 minus 1, which is going to give you ar squared. If you want to, you can determine the fourth term. So T4 is equals to ar cubed. The other technique we could use to get this is we have T4 is equals to ar to the power 4 minus 1, which is going to give you ar cubed. Alright, now that we know this, let's find Sn. And we said to get Sn, we basically need to add all of the terms. So a plus ar plus ar squared plus ar cubed. We've got the ellipsis. Our last term is ar to the power n minus 1. Now, unlike with the arithmetic sequence, with the geometric sequence, what I'm going to do now is I'm going to multiply the same Sn that we have by the value of r. So, a times r, that's going to give me ar. Notice where I'm writing it. It's important that you write it right underneath the term which is matching. ar times r, that's going to give you ar squared. Ar squared times r, that's going to give you ar cubed. You can see the pattern. We're going to have ar to the power n minus 1 here. Now, ar to the power n minus 1 times r, that is just going to give me, if my pen will allow me to give it to me, ar to the power n. How did I get this, you ask yourself? Well, I'm going to write it here on the left margin. We've got ar to the power n minus 1 times r. According to laws of exponents, this is ar to the power n minus 1 plus 1. When we multiply numbers of the same base, we add the exponents. The ones will cancel, you remain with ar to the power n. Wonderful. Let's get the straight line going again, because straight lines are good. Life is great. Ba-da-da-da. Okay, you did not just hear me say that. So what I could do now is, I could say, what do I get if I say rsn minus sn? So, 0 minus a, that's going to give me minus a. ar minus ar, that's 0. Ar squared minus ar squared, that's 0. Ar cubed minus ar cubed, that's 0. Ar to the power, okay, let me first put the ellipsis here. Ar to the power n minus 1 minus ar to the power n minus 1. That was difficult to say. That's 0. Ar to the power n minus 0, that's going to give you ar to the power n. If I write this properly, I'm going to have rsn minus sn is equals to negative a plus ar to the power n. Let's see, I can say rsn minus sn is equals to, let me swap these around, just so that I have a consistency. Now I can take out a common factor. My common factors sn here remain with r minus 1. This is equals to my common factors a, I remain with r to the power n minus 1. Since I'm solving for Sn, let me divide by r minus 1 both sides, so divide by r minus 1. This is going to cancel this. And I am going to have Sn is equals to a into r to the power n minus 1 all over r minus 1. Life is great. You have proven your geometric series. Now you can celebrate. And also remember that this question is about 4 or 5 marks. It's worth 4 or 5 marks in your exam. Okay, that was a lot of work. Let's look at the next section. We have an example. 4, 16, 64. Okay, let's go to the writing pad and write this down. And a new sheet. So we've got 4 plus 16 plus 64 plus ellipsis. Let's go back to the question. The question says determine S50. All right, so first of all, this is a geometric sequence. How do I see this? 64 divided by 16 gives me 4. 16 divided by 4 gives me 4. I have a common ratio. So Sn is equals to a into r to the n minus 1 all over r minus 1. So this is going to give you the value of a is 4 into 4 to the power 50, because the question wanted us to determine S50 minus 1. Oops, sorry, you guys are not seeing this. There we are. So basically, we calculated the value of r by saying 64 minus 16 is 4. 16 divided by 4 is 4. We have our common ratio, so we just substitute everything into the formula. The question wanted S50. This implies that the value of n is equals to 50. So divide this by 4 minus 1. You will type this in your calculator and get a very large number. I'll leave the work up to you to calculate it. Anyways, let's look at the next question. Determine S49. This is basically the same procedure. Let's take you to the writing pad. So we want S49. Once again, Sn is equals to a into r to the power n minus 1 all over r minus 1. So S49, this is going to be 4 into 4 to the power 49 minus 1 all over 4 minus 1. This is also going to give you a very large number. Leave it up to you to do the calculation. Next question says, hence, determine term 50. Hence meaning use the calculations from the previous question to answer this question. All right, let's have a look at it. Notice that the questions we've been working with so far have only involved S, so Sn, S50. But let's look at something. There's an important rule you need to take note of. S1, the sum of the first one term is equals to the first term. S2 is going to be T1 plus T2. But T1 is actually S1, so I can replace this by saying S2 is equals to S1 plus T2. Wonderful. S3 is equals to T1 plus T2 plus T3. But T1 plus T2 is actually S2. So I can say S3 is actually S2 plus T3. If I want S4, this is going to be T1 plus T2 plus T3 plus T4. T1 plus T2 plus T3, that is actually S3. So this is going to be S3 plus T4. So the rule, the general rule we can determine here is, to get Sn, I need to say Sn minus 1 plus Tn. And therefore, to get Tn, I'm going to say, if I play around with the formula, Sn minus Sn minus 1. How is this helpful to us? Let's check the question. We need to determine T50. So, to get T50, according to the formula that we just worked out, T50 is going to be equals to S50 minus S49. Now you understand why the question said hence, meaning we have S50 up here. We have S50 right here. So this is where we're calculating S50. This is S50. We have S49 down here. To get term 50, we simply just substitute S50 minus S49. Then we get our term. If I were you, I would write this down somewhere in my study book because this formula is not in the exam. It's not in your information sheet, but it's rather important to understand the relationship between a pattern and a series. I hope this was clear to you guys. Let's move on to the next section. We're talking about a converging geometric series. What does converge mean? If you think about English, in English the word converge means to meet. But let's see. When we're talking about a converging series in mathematics, a converging geometric series is a series in which the terms are approaching a specific value. I'll give you an example just now. A geometric series is only converging, or we say the sequence is convergent, if the ratio is between -1 and 1. Here are some examples of converging geometric series. 8 plus 4 plus 2 plus 1. Let's go to the writing pad to actually understand why we're saying this is converging. So, we've got 8 plus 4 plus 2 plus 1. We said earlier converging sequences approach a certain value. Let's quickly calculate the value of r here. So I could say to get the value of r, let me take, just because I want to, t3 divided by t2. You can take t4 divided by t3 or t2 divided by t1. You will still get the same answer because we've identified it's geometric. So this is going to be 2 divided by 4, which is giving us 1 over 2. So to get the next term, I'm going to say 1 multiplied by my common ratio, that's going to give me 1 over 2. To get the next term, 1 over 2 multiplied by my common ratio, that's 1 over 4. To get the next term, 1 over 4 multiplied by my common ratio, that gives me 1 over 8. If you look at these terms, you will see that the more we continue, the closer and closer these terms get to 0. 1 over 2, that's 0.5. 1 over 4, that's 0.25. 1 over 8, if I'm not mistaken, that's 0.0625. You will notice the values are getting smaller and smaller. They're getting closer and closer to 0. That's why we say that the sequence is converging. Notice that the value of r is 1 over 2. The value of r is between -1 and 1. Hence, we can say that the sequence is converging. We say this is a convergent sequence. I hope that makes sense. Here's another example of a converging series. So now, why do we need to know about a converging series? We have what we call an infinite geometric series. An infinite geometric series, which is also known as a sum to infinity, is the sum of terms in a convergent geometric series. The geometric series must be convergent for the sum to infinity to exist. I'll repeat this again. The geometric sequence or the geometric series must be convergent for the sum to infinity to exist. This is important. The formula for calculating an infinite geometric series is just given as that. A is the first term, r is the common ratio. There we have it again in bold. If the series is not convergent, if the value of r is not between -1 and 1, the sum to infinity does not exist even if your calculator gives you an answer. That's interesting. You're not required to prove the sum to infinity, thank goodness. Alright, here we have a sequence. We've got 54, we've got 18 and 6. The first question says, is the sequence convergent? Explain. Let's go to the writing pad. So the terms we have here, we've got, let me scroll down. We have got 54 plus 18 plus 6. In fact, in the question, it was a sequence. So Let me get rid of the pluses and replace them with semicolons so that we stick to what the question has. Is the series convergent? Let's check. R is going to be, I can say 6 divided by 18. This gives me 1 over 3. I could have also said R is equals to 18 divided by 54. This is still going to give me 1 over 3. The value of R is between -1 and 1. Therefore, the sequence is convergent. Life is great, you guys. Next question, let me just take you to the notes. The next question says, determine the sum to infinity if it exists. Well, we already know that the sum to infinity does exist because we have proven that it is a convergent sequence. So, let's just write down the formula and do the calculation. S infinity is equals to A over 1 minus R. Now, the first term here is 54. So let me write that down. This is 54 over 1 minus the value of R, which we calculated as 1 over 3. So that's 54 over 1 minus 1 over 3. This is going to give me 54 divided by 2 over 3, which I can just rewrite as 54 multiplied by 3 over 2. Now, 2 goes into 54. Let's see how many times is that. 2 goes into 54 26 times. 26 times 3. That's 26. 52. Okay, my memory is not serving me so well. My mental math is not serving me so well. 26 times 3. That's going to give me 78. So the sum to infinity in this case, S infinity, is 78. There we are. We're done. Life is great. Okay, there we have another question. We're given this geometric series. And let me just write it down on the writing pad. We have a new sheet on the writing pad, and let me write down the question. So, we have 8 into x minus 1 squared plus 4 into x minus 1 plus 2 plus ellipsis. So, question says, determine R, the constant ratio of the series in terms of x. We are told that this is a geometric series or geometric sequence, so we can safely assume that R does exist. Let me take T2, so R is equals to T2 divided by T1. This is going to give me, let me just simplify this, 4 into x minus 1. Because the brackets are squared, I could say x minus 1 into x minus 1. This is going to cancel that. I remain with 4 divided by 8. That's going to give me 1 over 2 into x minus 1. This is the value of R. We are done. Let's go back to the notes. The question says, determine the values of x for which the series will converge. So, once again, if you can remember what we said earlier, for a series to converge, oops, you are not supposed to see that. That was a mistake. For a series to converge, the value of R must be between -1 and 1. So let's substitute the value of R. This is 1 over 2 into x minus 1 is less than 1. Now for those of you who would remember from grade 8 and 10, to solve this inequality, we need to multiply both sides of the inequality with the denominator. So this is going to become -2 into x minus 1 is less than 1, which is less than +2 into x minus 1. Now we need to solve for x. To simplify my life, why don't I divide everywhere with, let me use +2 instead of -2, because that way I won't need to change my inequality sign. So divide by 2 here. I'm going to have to divide by 2 and divide by 2. So this is going to cancel that. This is going to cancel that. We're going to have here -x minus 1 is less than a half, which is less than x minus 1. If we simplify this, negative x plus 1 is less than 1 over 2, which is less than x minus 1. In this case, I can group my variables one side and my numbers one side. Let's see. Let me take the x over to the other side. So I'm going to have here negative x minus x is less than, let me bring the 1 over to the half. So this is 1 over 2 minus 1, and then I'm going to bring this half, this negative 1 over. This is plus 1. I'm going to be left with 0 this side. So I'm going to have negative 2x is less than negative 1 plus 1. This could give you 0. So this is 1 over 2, which is less than 0. This is beginning to look very interesting. But anyways, I can divide by negative 2, divide by negative 2, divide by negative 2. I'm going to have x, the inequality sign is going to change direction. 1 over 2 divided by negative 1 over 2. 1 over 2 divided by negative 2. This is the same as 1 over 2 times negative 1 over 2, which is going to give me negative 1 over 4. And I could just leave it like that. There we are. X is greater than negative 1 over 4. 0 obviously is not important anymore. Next question. Explain why a series with a common ratio of x squared plus 2 will never converge. Okay. So, let's have a look at this. We're saying we've got the value of r as x squared plus 2. Why will this never converge? If you think about it in terms of functions from grade 10, if I had to sketch this as a function, it would look something like this, with your turning point being at 2. What you will realize is that x squared plus 2 is always going to be positive. It is always going to be greater than 1 for that matter, because the minimum value is 2. So because it's greater than 1, the series will not converge because r is not between negative 1 and 1. So I could say r is greater than 1. Therefore, series does not converge. I hope that this makes sense. All right, moving to the next section. Sigma notation. This is the last section. Now, sigma notation is basically a shorter way of asking you to calculate Sn. So let's say this is what you have, your sigma sign. Now, because you're seeing sigma, just remember Sn. Now, to get the first term of the series, we need to substitute the value of n into this expression here. I'll show you an example just now. To get the last term, we need to substitute the top value into the value of Tn, into the expression Tn. To get the number of terms, we always say top minus bottom plus 1. Keep this formula in mind. Please take note of this because it is quite important. The expression of Tn will either contain the common ratio or the constant difference depending on whether or not it is arithmetic or geometric. You would use these values to calculate Sn. So let's look at an example. The question says evaluate the following. Let's go to our writing pad so that we can have a look at this together. I'm going to open a new sheet and let me copy down the question. So I've got the sigma sign here. I've got k is equals to 1. My expression is 3k minus 4. And then right at the top, I've got 12. Remember, sigma always equals series. So think Sn. Looking at this, I could see that this is an arithmetic series. How did I see that? Well, if the highest exponent of the variable is 1, it's an arithmetic sequence. As long as the exponent is not the variable, the highest exponent of the variable is 1. Therefore, it's an arithmetic sequence. So, To get the first term, I'm going to substitute k is equals to 1 in here. So 3 into 1 minus 4, this is going to give you negative 1. I can calculate the last term by substituting the top value into the expression. So 3 times 12, that's 36. 36 minus 4 gives us 32. Here's something interesting. The common difference is always the coefficient of the variable. The common difference is 3. The number of terms is going to be the top number minus the bottom number plus 1, which is going to give you 12. Now we can go ahead and find Sn. So, Sn is equals to n over 2 into a plus l. So this is going to give me 12 divided by 2 into negative 1 plus 12. This is going to give me 12 divided by 2, that's 6, into 12 minus 1 is 11. My answer is 66, and I am done. Just like that. That's sigma notation. So remember, when you're seeing sigma, just remember that it's asking you to find Sn. Right, here's another question. It says calculate. So once again, we're finding Sn. Now, if you'd like to, pause the video and see if you'll be able to answer this question. Let's have a look at it together. So let's go back to the writing pad, and I'm just going to start a new sheet here. So let me write down what I'm given. I'm given sigma, and then I have p is equals to 0. The top value is 20, and this is going to be 2 to the power p minus 2. Now, to get basically, before I get to that, this is a geometric sequence. How do I see that it's geometric? The variable is an exponent. To get the value of r, if the variable is positive, the value of r is the base. If the value of r is negative, so let's say we had 2 to the power minus p minus 2. If the value of the variable is negative, what you do is you swap the numerator and the denominator of the base in order to get the value of r. I'll repeat. If the value of r is positive, sorry, if the value of p, the variable, is positive, if the variable is positive, take the base of that exponent as the value of r. If the variable is negative, swap the numerator and the denominator to get the value of r. We're dealing with the geometric sequence, ladies and gentlemen. To get the value of a, I substitute the bottom number into the expression. So that's 2 to the power 0 minus 2, which is just going to give you 1 over 4. The number of terms in this case is going to be 20 minus 0 plus 1, which is going to give me 21 terms. This is a geometric sequence, so Sn is equals to a into r to the power n minus 1 all over r minus 1. This is going to give me the value of a is a quarter into 2 to the power 21 minus 1 all over 2 minus 1. You could substitute this into your calculator and then get the final answer. Sorry about that again. Alright, I hope that this makes sense to you guys, that you're getting a better understanding of sigma notation, because I know it can be tricky at times, but it's really not that complicated once you understand the working. Alright, the next question says, evaluate the following if it exists. Alright, life is great here. Let's go back to the writing pad and let's copy down the question. So we've got sigma, and we are given m is equals to negative 1. Is it m? Oh, n, sorry. Let me just correct this. The variable is n is equals to negative 1. We've got infinity at the top, but that's an interesting one. And then we've got 3 to the power 1 minus n. Now, you would notice that with the previous example, I did not calculate the last term. And that's because the formula for the sum of a geometric series does not require that we have the last term. That only applies to an arithmetic sequence. So now, same thing here. I'm not going to stress about the last term. What I am going to notice is that my variable is an exponent. Boom. This is a geometric sequence. So to get the value of r, notice that my exponent, the variable is negative, so the value of r is 1 over 3 instead of just 3. To get the value of a, I have to substitute the value of n into the value below the sigma sign into the expression. So that's 3 to the power 1 minus minus 1, which is 3 to the power 2, that's 9. The number of terms, well, you could say infinity minus minus 1 plus 1, but because we've got infinity at the top, the number of terms is automatically just going to be infinity. All right, we're calculating the sum to infinity. Does the sum to infinity exist? Let's take note of something. The value of r is actually between negative 1 and 1. The series is convergent, therefore the sum to infinity does exist. S infinity is equals to a over 1 minus r. This is going to be equals to the value of a, that's going to be 9 over 1 minus a third, which is also going to give you, let's see, this is going to be 9 minus 2 over 3, which I can write as 9 times 3 over 2. And that's going to give me 27 over 2. I am done. That's sigma notation in short, ladies and gentlemen. All right. Identifying an arithmetic sequence from the general term. Sorry, I made a little bit of a typing error here. I've already mentioned this to you in the previous example, that if the term is linear, meaning the highest exponent is 1, the sequence is arithmetic. These are all examples of arithmetic expressions. Common difference is always the coefficient of the variable. So if we look at this 2n minus 1, common difference is 2. If we look at this expression, the common difference is negative 4n because you have to simplify it first. The common difference is a half. To get the first term of the sequence, you just substitute the number below sigma into t, and I've already mentioned that. To identify if it's a geometric sequence, we said if the general term has an exponent or variable, it means the sequence is geometric. That marks the end of our lesson on sigma notation. I do hope that you guys found this productive. I do hope that you enjoyed it. If you liked the video, please give it a like, give it a thumbs up, smash that like icon. Please share the video with other people. Please subscribe to the channel so that the channel can grow and we can share the content with many other people. I'll check you guys in the next one. Until we meet again, keep being cool, keep well, keep studying. Peace out.